So we got another one on our next one over here. However, there's two inequalities that are going to come up a lot for the remainder of the chapter. X and y are greater than or equal to 0. If we were to do it the same way we did the first example, we'd have to draw 4 inequalities, 4 half planes. Way too much fun. Well, if you have these two inequalities and only these two inequalities, instead of drawing 4, you can label your answer in one specific quadrant. Which quadrant are the x's and y's both greater than or equal to 0? Quadrant 1, the top right one. So if you have these two inequalities appearing, then what you can do is, when you're doing your final answer, just shade only the region that's in the first quadrant. So instead of having to draw 4 half planes, we now only have to draw 2. So if that were the case for this first guy here, you would just be drawing this little triangle guy, because that's the only part of that answer that's in the first quadrant. So if we had these two inequalities plus x and y greater than or equal to 0, you would only have this triangle area because that's the only part that's within the first quadrant. Nothing else would be shaded, just this triangle. Correct. Inequalities, right. So what this says is x greater than or equal to 0 means you're to the right of the y-axis. Y greater than or equal to 0 means you're above the x-axis. So if you had this black region and you had to be right of the y and above the x, it would have to just be this triangle. And that's it. So we wouldn't shade any of the other part because that's not in the first quadrant. Comment. Your feasible region can never, ever, ever cross a boundary line. So you can't have a part here and a part over here. Nope. They got to be together. Okay. You can't have two feasible regions, right? They can't be separate somehow. Mm-hmm. So for instance, if you had this and this, then that violates the line y equals 0. It's crossing y equals 0. And we can't cross a boundary line. Is that okay? Yes. Yeah. Any line that's created from an inequality is called a boundary line. Mm-hmm. Okay. So going back to the other one, now that looks even worse. Going back to the other one, we're going to draw the first two inequalities, but then when we do our shading, we're only going to care about the first quadrant because that's what the last two inequalities say. So for the very first inequality, we have x plus 3y equals 12. Ah, that's a 3. I hope I have enough room. What's the x-intercept? And what's the y-intercept? Questions on that? Oh, I got it. I'm a winner. Which is ironic because tonight I will be having a chicken dinner. Solid or dotted? Solid. Oh. Am I shading above or below? Below, why? And you need two parts of that. 0, 0 makes it true, and 0, 0 is below. There you go. So 0, 0, the origin is below the line. It makes the inequality true, so we're going to shade below. But what I just said was we're just going to keep our shading in the first quadrant. Now, you can go outside of the first quadrant. That's cool. But then shade your first quadrant region the darkest. That's fine. This is hard to do. I think this is offset a little bit. I'm going to blame the technology. I'm not going to blame myself. Why would I do that? The second one, x plus y equals 6. What's the x-intercept? What's the y-intercept? Oh, geez. Oh, gosh. It's getting worse. Stay. Good job. Above or below shading? Below. 0, 0 is below line. 0, 0 makes it true. We're going to shade below. Again, keeping it just in the first quadrant. So as far as where they overlap, it's this, hold on, I'm trying to think of the proper math term. Quadrantal figure, four-sided figure. There you go. That's good. Let me shade it in. Stay in the lines, Mike. You can do it. So the black regions for both parts are called feasible regions. Your final answer.